In this video, we are going to take a look at applications of spherical coordinates in computing an integral over a hemisphere with the equation x squared plus y squared plus z squared, where y is greater than 0. So it's not the whole sphere, it's just half of a sphere. Now look at the picture that I made with Calcplot 3D. So you can see that this is just the right side of the sphere. So what we need to do first is figure out what will be the spherical coordinate limits, right? So first we remember that we got rho, phi, and theta in spherical coordinates, and rho is the distance from the point to the origin. So let's say we got an arbitrary point on this solid, and we fix phi and theta so they don't change, then rho will become over here is 0, and over here, because you're on the sphere, and the sphere was x squared plus y squared plus z squared equal 25, so the radius of it was 5. So rho will go from 0 to 5. Now, what about a phi? So phi is the angle with the z-axis. So this would be, let me try to use a different color. So this would be right here. This is angle phi. So on the top right here, the phi angle with the z-axis is 0. And then as you keep going all the way around and under here, and that's where you stop, your angle phi will go from 0 to pi. Right? Pi is 180 degrees. So on the top, the angle is 0. Over here on the bottom, the angle is going to be pi. Now, finally, theta. So this is going to be interesting. So theta is the angle with the positive x-axis. So theta is not going to be 0 to 2 pi all the way, because it's going to start right here and then it's going to end over here, right? So you're going like this way. And so theta is also going to be from 0 to pi here, okay? All right, so, and because it's not going to go all the way around. All right, so let's see if we can set that up. So see here, we're going to be 0 to pi. Then for phi is 0 to pi also. And then for rho, we go from 0 to 5. Okay, now what are we integrating? So number one, we are integrating x squared plus y squared plus z squared squared. Everybody needs to know that in spherical coordinates, x squared plus y squared plus z squared is going to be rho squared. So we are really integrating that squared, which is rho to the fourth. And also in spherical coordinates, we always add an extra factor, which is called a Jacobian, and it's like it's coming out of nowhere, but it's coming out of switching from rectangular to spherical coordinates. So that's extra rho squared sine phi. Okay, so in conclusion, what are we integrating? So first we are integrating rho squared squared, so that's going to be rho to the fourth, and then we are multiplying that by that extra factor, which is rho squared sine phi. Okay, and so you can actually combine these rho things into rho to the 6, but let's see if it's gonna take it. Okay, so it looks like that's right. Now let's see if we can integrate. So let me show you the integration. So that should be pretty straightforward. So we've got 0 pi, and then 0 to 5, and then we got rho to the 6 sine phi. And then we do d rho, d phi, d theta. Now, the easy part here is that this integral is actually splittable into 3, because the limits are all constants and the function itself that you're integrating can be split apart. It's a product. So for theta, since we don't have theta at all, that's just going to be 0 to pi d theta. For phi, it's going to be 0 to pi sine phi. And for rho will be 0 to 5 of rho to the 6. Okay, now that we split them, let's compute them. The first part is pretty easy. Integral of d theta is just theta, right? So because this is just 1. And then we substitute 0 pi. Now, integral of sine phi is negative cosine phi. So hopefully you already know that. Substitute 0 pi. And then here we're going to get rho to the power 7 divided by 7. And we substitute 0 and 5. Okay, so from the first integral, we just get pi. Now be very careful here, because sometimes people think that this is going to be 0 and it's not. If I substitute pi, cosine pi is negative 1, but then there is another negative, so this is really going to be 1. Subtract Now substitute 0. What happens when I substitute 0? Cosine 0 is 1, and then there is a negative, so this will be negative 1. And then over here, this is just 5 to the 7 divided by 7. So I get pi times 1 plus 1 is 2, and then 5 to the 7 divided by 7. So let's see if we can put that answer here. And that becomes 2 multiplied by 5 to the power 7 divided by 7 and pi. All right.